Hello everyone. So I hope you all are doing well. I'm receiving a lot of requests and sorry that I'm not able to cater to your request on time, but I definitely will do so whenever I get time. I do need your support and feedback so that we can improve and we can grow together and we can make learning possible in this pandemic situation. Please stay safe, stay healthy. So, without any further ado, we'll begin the topic for today. We are going to discuss everything about DCP, dry chemical powder. Okay, it is in fixed installation as well as in portable ones. So, we'll start with the portable first. So, when we talk about dry chemical fire extinguishers, it extinguishes the fire primarily by interrupting the chemical reaction of the fire triangle. So, I hope you know the fire triangle. So, when we talk about this fire triangle, so it should be, I think, fire tetrahedron because there are three elements primarily. The one is the heat, the fuel, and the air. And the tetrahedron, we talk about the fourth element, that is chain reaction. And this chemical powder extinguisher is breaking this chain reaction. Remember, it doesn't have a cooling effect altogether, which you will find with foam type or a water type. Okay, DCP doesn't has this property. Now, today's most widely used type of fire extinguisher, when we talk about multi-purpose dry chemical that is effective on almost all the classes of fire. So except you, if you leave the oil of kitchen, the kitchen fire, rest on all, this DCP is very much active. We can all use it on all classes of fire. This agent also works by creating a barrier between the oxygen element and the fuel element on class A fire. So it acts as a barrier. Okay. Ordinary dry chemical is for class B and C fires only. We have two type here. We have multi-purpose dry chemical and we have ordinary. So multi-purpose can be used on all the classes except that kitchen one I said, and the ordinary chemical is used only for B and C fire. It is important to use the correct extinguisher for the type of fuel. Using the incorrect agent can allow the fire to reignite after apparently being extinguished successfully. So we we are supposed to use, these were introduction, that we are supposed to use the correct form of fire extinguisher, otherwise it will become very difficult. Now, what does it contain? It doesn't contain only this one. I'll be discussing more elements further, but for your knowledge, it contains sodium bicarbonate with a waterproofing agent such as magnesium stearate to prevent caking. So it doesn't create caking, so we have this sodium bicarbonate and magnesium stearate. So you can see this is a portable extinguisher where you find its part. Okay. Now, when we move ahead and we see, explain this figure, the container has the container shown here in this figure holds a cartridge containing liquid carbon dioxide. So it has a cartridge that you see, it has liquid CO2. CO2 always, when we talk about fixed CO2 installations also, they are stored in the liquid form only, because compressed form is in liquid form. Now, on piercing its seal with the plunger pin, the gas is delivered through a tube to the bottom of the casing. Now, a gas is delivered to the tube. Okay, the gas is delivered through the tube. Now, you see here a tube is attached and through it, it is delivered to the bottom. Okay, now this gas, when we plunges it, then it breaks the seal and then the gas goes to the bottom. Remember it, this is very important. The carbon dioxide is going to the bottom of the container where it enters the dry powder and carries it up through the discharge tube, because once it leaves the air, now you see, you release the air at a particular surface. What will happen after striking that surface? It will try to come up. Okay, means from the direction you are leaving, it will come to that direction only by reflecting in different way. So the same way it is happening. Gas is coming, projecting here, and then again it tries to goes to from this pipe. Okay, discharge tube, and that is known as discharge tube. The entrainment and CO2 pressure build up within the casing forces all the powder through the discharge nozzle. So all the powder is forced because of the pressure. The powder penetrates the flame as a cloud of fine dust which appears to interfere with the chemistry of combustion. The heat of the fire will cause the sodium bicarbonate to decompose to produce carbon dioxide, which helps to smoother the fire. Now smoothing is happening by sodium bicarbonate, that is getting extinguished and producing CO2. So CO2, you know, that's a bad supporter of fire. Now the decomposition is taking heat may give more cooling effect. Okay, now the extinguisher discharges in only 15 seconds, and so you may wondering, I said that it doesn't produce cooling effect. So the after the reaction that it may give some, but initially that is cooling effect is not produced by this extinguisher. Now the extinguisher discharges is in only 15 seconds, and it is thus important to aim the appliance accurately, because if you don't aim it accurately and if you aim here and there, then your the powder will also get wasted and you will not be able to extinguish the fire altogether. The operating procedure of the container is high and is consequently hydraulically tested to a pressure of 35 bar. So we are testing this apparatus as 35 bar. Now when we talk about maintenance and testing, all possible extinguishers are pressure vessel and must therefore be regularly checked. So it is regularly checked. The dry powder extinguisher is tested to 35 bar once every 4 years. So this is a requirement that 35 bar we are checking once every 4 years. Most extinguishers should be tested by discharge over a period of 1 to 5 years. It is tested from 1 to 5 depending on the extinguisher type. Where practicable, the operating mechanism of portable extinguisher should be examined every 3 months, because it has to operate in the case of an emergency. It has to operate. Their plunger has to be checked for free movement, vent holes to be clear, and cap threads tightly greased. Most extinguisher with screw-on cap have a number of holes in the threaded region. So you must have seen on the threaded region there are a number of holes. These are provided to release pressure before the cap is taken off. They should be checked to be clear. So they have to be checked before this clear. Sometimes this question is asked, why there are holes are provided. So before the cap is taken out, it is just to release the pressure inside. The type, number and location of portable and semi-portable extinguisher are supplied to the cargo vessel according to the SOLAS flag and classification requirement. All firefighting must be in constant state of readiness and be regularly properly maintained. Any valve in this system are to be operated and provided free every. Any defects with the equipment are to be reported to the company immediately. Okay, so these are there. Now when we talk about fixed installations, then ship intending to carry flammable produce are to be fitted with fixed dry chemical powder type extinguishing system. Now fixed type of this DCP is only available fixed wherever flammable products, so you may find on tankers. Okay, the deck in the cargo area and the bow or the stern handling area if applicable. The system and the dry chemical powder shall be adequate for this purpose and satisfactory to the society. The system is to be capable of delivering powder from at least 2 hand hose lines or a combination monitor hand hose. So it has to be 2 handheld hose or to be a monitor hand hose to any part of the above deck exposed cargo area, including above deck product piping. These systems shall be activated by an inert gas. There has to be inert gas which has to be activated, such as nitrogen, used exclusively for this purpose and stored in pressure vessel adjacent to the powder containers. Now drawings of the system and details of the dry chemical powder are to be submitted to the society for approval. It is being done. That is a very common thing. Fire extinguisher unit having 2 or more monitors, hand hose lines or combination thereof shall have independent pipes with a manifold at the powder container unless a suitable alternative means is provided to ensure proper performance as approved by the society. Where two or more pipes are attached to a unit, the arrangement shall be such that any or all of the monitor and hand hose lines are capable of simultaneous or sequential operation at their rated capacities. Now we'll discuss it in detail, whatever we have seen. In general, dry chemical system to describe the type of fire extinguishing system, also called powder system, dry powder system, dry chemical powder system, etc. To describe the dry chemical itself, we use the term powder. Okay. Now, dry chemical powder system. A dry chemical powder system is defined as supply of powder that can be automatically or manually activated to discharge through a distribution system into the protected item area. The system may also include auxiliary equipment. So, in auxiliary equipment also we use this. Now, it is of a very small particles, usually of. Now, here you see there are much more components: sodium bicarbonate, potassium bicarbonate, urea potassium based bicarbonate, potassium chloride or monoammonium phosphate with added particulate material supplemented by special treatment to provide resistance to packing, resistance to moisture absorption, that is caking. Caking should not happen. There we are adding magnesium stearate to avoid this caking, and the proper flow capabilities so that it flows properly. The powder is stored in a pressure tank and is discharged by using a propelling gas. So as you saw in portable also we have this cartridge which is usually of CO2. Now here also the powder is stored in a pressure tank because with pressure it is going to act. Okay, and now it is discharged by a propelling gas. Normally nitrogen, but carbon dioxide or air is also used for some application. Okay, separately stored propellant. The principle most frequently used in fixed and large mobile system is to have the propellant. Now this propellant here with the large system, whether it is fixed or whether it is major portable fire extinguisher, those are nitrogen stored in separate tank. Now these nitrogen is stored in separate tank. Now there you have tanks are separate, but it is under one container only. In one container in portable system you see there are powder, and then we have a cartridge which is filled with CO2, and both are in one container itself. So here you have two separate tank for nitrogen and as well as for the powder. The powder is stored in a tank at atmospheric pressure and pressurized when the system is activated. This is done in two ways. Now, how do we pressurize the tank where the powder is stored, which is already a pressurized tank? Now, these are done in two ways. That is direct pressurizing without pressure regulator between the propellant container is used for portable extinguisher, and small fixed system with set-off possibilities in dry chemical discharge line. Pressurizing through a pressure regulator is the normal principle for fixed installation. So with pressure regulator for fixed installation, we are pressurizing with what we call is known as pressure regulator. Okay, which is comes under direct pressurizing. And the basis for the system further described here. This method gives the best control of the discharge and ensure a steady discharge rate through the whole discharge period. So it ensures that there is a steady discharge throughout the operation. Okay. Now theory about combustion and fire extinction. Combustion is a chemical reaction that requires the concurrence of a fuel, a combustion supporter, generally oxygen in the air, and energy, heat. During the combustion of a substance, some interatomic bonds are broken and extremely reactive entities, free radicals, are generated, which, taking part in combustion, allows its propagation. The above first three factors need to be present at the same time to ensure ignition, while free radicals are the vehicle by means of which combustion propagates itself. Through a series of chain reactions that they provoke, free radicals liberate a great quantity of energy that shows itself in the emission of heat flames, thus allowing the reactions self-support. This is the reason why in the most recent theories on combustion, the so-called fire triangle at whose vertices stand fuel, combustion supporter and heat respectively, has been changed into tetrahedron. So we already discussed, that's why I'm reading just it. That annexes free radicals at the added vertex. Best known theories on fire extinction by dry chemical state that combustion is the fundamentally limited and interrupted because of the following phenomena. Now, endothermic scission of dry chemical main component, usually a bicarbonate of sodium, potassium or other salt, we have already discussed, that causes absorption of heat and consequently favors extinction. Production of carbon dioxide consequent to the scission of extinguishing dry chemical that reduces the quantity of oxygen involved in the combustion and formation, in some cases of water vapor, that once more reduced oxygen. In most recent time, however, the theory of free radical has been more and more created because it has been demonstrated that their activity is slowed down until completely blocked by the action of other radicals generated by certain substances which have particular properties, is dry chemical. When subjected to the action of heat, okay, conclusion. When projected onto fire, extinguishing dry chemical actually interfere with the combustion chain reaction to hinder their propagation. The surface area on contact between flames and a dry chemical, that is, the smaller the powder particle, the more effective is the dry chemical itself as a fire extinguishant. When the above indicated phenomena occur and free radicals are reduced, there is corresponding progressive decrease of the combustion reaction. The whole process culminates in complete extinction. Now, use. Types of hazards and equipment that can be protected using dry chemical system include the following: flammable liquid and gases, extinguishing flowing flammable liquid fires, especially class 1 liquids may result in a reflash unless all sources of ignition have been removed. Flammable gases present at potential explosion hazard if the flow of gas is not stopped before or during the extinguishing. Now, combustible solids have burning characteristics similar to naphthalene and pitch, which melt when they involved in fire. Electrical hazards such as transformers or oil circuit breakers, we do also use on electrical fires as well with DCP, but it will permanently damage. Okay, that is the reason why it is we avoid and we use CO2 and on the extinguishing electrical fires. Now, textile operations subject to flash surface fire where bicarbonate based dry chemical is used. Water shall be provided to extinguish possible smoldering or deep seated fire. Ordinary combustibles such as wood, paper or clothes using. So we are using on all this fire that is being described here. Restaurant and commercial hoods, ducts and associated cooking appliances hazards such as deep fat fryers. Some plastics depending upon the type of material and its configuration of hazard. For more specific information, we do consult the manufacturer. Now, what are the limitations when we talk about dry chemical extinguishing systems shall not be considered as satisfactory protection for the following: chemical containing their own oxygen supply. There are some chemicals which have their own oxygen supply, because of which certain reactions it emits oxygen, such as cellulose nitrate. We cannot be using on cellulose nitrate. Now, combustible materials such as sodium, potassium, magnesium, titanium and zirconium, we cannot use there. Deep seated or borrowing fires in ordinary combustibles where the dry chemical cannot reach the point of combustion. Okay, where it is a deep suited fire, as we saw here in textile industry, there are deep rooted fires there is, so where we need water, so we cannot be using this. Before dry chemical extinguishing equipment is considered for use to protect electronic equipment or delicate electrical relays, the effect of residual deposit of dry chemical on the performance of the equipment. So that's why we said we can be using on electrical fire, but it will damage the component because there are residues. That is the advantage of CO2, which I have already covered in a video, CO2 system. So you can watch that video. That CO2 doesn't leave any residue, whereas DCP will leave residue, which will damage the component. Okay. Multi-purpose dry chemicals shall not be considered satisfactory for use on machinery such as carding equipment in textile operation and delicate electrical equipment, because upon exposure to temperature in excess, a relative humidity exceeds of 50%, deposit will form that may be corrosive. So whenever powder is remained, the residue, they are in fact corrosive in nature. Dry chemical when discharged will drift from the immediate discharge area and settle on surrounding surface. Prompt cleanup will minimize possible standing or corrosion of certain material that may take place in the presence of moisture. Now, personnel safety. Safety requirement. In total flooding and local application system where there is a possibility that personnel may be exposed to a dry chemical discharge, suitable safeguards shall be provided to ensure prompt evacuation of such locations and also provide means for prompt rescue of any trapped personnel. Safety items to be considered shall include both but not be limited to personal training, warning signs, discharge alarm. Okay, so these are safety precautions that we are supposed to take. Now, when we talk about technical description, the dry chemical system can be activated automatically by detection or manually to discharge the powder through nozzles, handguns or monitors. We have already discussed the protected area. The powder is contained in a pressure tank and is discharged with the aid from a propellant gas, normally nitrogen N2, but carbon dioxide CO2 on or air also can be used. So these are propellant gas which we are using. CO2 that I've already discussed in a portable extinguisher, and N2 that is in fixed installation, nitrogen. Now when we dry cleaning system available in wide range of capacities and for different applications within marine and industrial use, the system can be arranged for automatic discharge when connected to a fire detection system, electric or pneumatic, remote controlled manual discharge using a pneumatic or electric system. Local manual discharge, the system modular design allows flexibility in the different applications. So we can have three different modes by which we can discharge. Now the powder tank. The powder tank is produced. Now we are describing all the components separately. The powder tank is produced according to standards of acknowledgement such as DNV or similar. The tank can be delivered with a certification from a third party such as DNV or similar classification and with the customer. Now safety valve, when we talked about, the safety valve is mounted on the powder tank to evacuate high pressure. So if there is a unnecessary sudden rise in the pressure, the valve is tested and opens at a pressure of 16.5 bar. Now pressure gauge. A pressure gauge is mounted on the powder tank to always show the pressure in the tank. What is the available pressure? So these are mountings of the tanks. This can be a question. Isolation valve is mounted between the powder tank and the pressure gauge. The valve is to be closed if the pressure gauge has to be changed, calibrated or similar. Nitrogen three-way valve. Now, the powder tank is pressurized with nitrogen through a nitrogen pilot line and three-way valve which is mounted at the tank. After a release, it is important that the powder hose or the pipe is cleaned with nitrogen to get all the powder out. There will be some residue which will remain in the line. So that is the reason why we are using nitrogen again to clean the full line, okay, by changing the direction of valve. So that is the reason why this valve is provided, three-way valve. Okay, the nitrogen gas will be pouring into the powder hose or the pipe instead of the tank, 3.7 liter. The filter is placed on the pilot line between the powder tank and the main valve to ensure clean nitrogen without any powder. Okay. Inline relief valve, the other component. The inline relief valve is mounted on the same pilot line as the filter, but after this, when the pressure in the tank has reached 10 bar, the valve will open up and let filtered nitrogen through with the pressure of 10 bar. Okay, whatever is the excess pressure that it will release. That is the reason why we have relief valve. We have pressure regulator. The regulator is mounted before the butterfly valve. The nitrogen pressure will be reduced from 10 bar to 5.5 bar before nitrogen is laid to the pneumatic actuator on the butterfly valve. Now there are bleeding valves. The bleeding valve is mounted after the pressure regulator. The valve is decreasing the pressure in the pilot line so that the pneumatic butterfly valve can be closed. Nitrogen pressure regulator. The pressure regulator is mounted on the nitrogen manifold. The regulator controls the release pressure in the powder tank. The regulator is designed for a pressure of 200 bar and the pressure out can be regulated from 0 to 21 bar. There are nitrogen cylinders. I talked about the two tanks. We have one storage tank for the powder and when we have a nitrogen tank. 40 liter nitrogen is used as propelling gas to release the powder from the tank. The cylinder is a standard 40 liter cylinder produced according to the European standards, and it has a quick opening valve for quick evacuation of nitrogen gas. Nitrogen cylinder valve. The valve is mounted on the nitrogen cylinder and is operated manually and pneumatically. The valve has a built-in pressure gauge and safety disc. Okay. Cylinder clamps. It will be delivered two sets of clamps for each cylinder. Each set consists of uni rail, two pieces, cylinder brackets and a bolt with nut. Butterfly valve with pneumatic actuator. The valve is mounted on the outlet of the powder tank and is operated pneumatically. The valve in addition fitted with the manual declutchable gear operator. Now there are pneumatic release cabinets also. The pneumatic release cabinet is supplied with a 1.3 kg pilot cylinder and a half 1 by 4 inch ball valve. Nitrogen pressure regulator. The pressure regulator is mounted on the nitrogen cylinder and is designed for a pressure of 200 bar. The pressure out can be regulated from 0 to 21 bar. Now there are other component, and that is powder nozzle. The powder nozzle is a half-inch spiral jet nozzle with a capacity of 0.44 kg per sec. Okay, so this was all about the component, that fixed firefighting installation, that is DCP. On tankers you will find it. We have discussed today about all the mountings, what is the tank construction of a nitrogen tank, or there are two separate tanks for the nitrogen and for the storage of the powder, how the system is working, what are the mountings on the tanks, how it is operating, and at what pressure water gases is used, what is the component of the powder, and we also discussed about the portable fire extinguisher and what is there the cartridge in, how the cartridge works and how the DCP comes out. We have discussed everything in detail. Thank you so much. I know I did just go through all those things because these are self-explanatory things. So I hope you know all those things, and you can pause the video and you can read between the lines and you can make note of all those things. Thank you so much. Thank you for your valuable time, and please do share your valuable feedbacks. All the best for your exams.